Right now, as you sit in the stillness of your room, you are moving at 1.4 million miles per hour. You cannot feel it. There is no wind rushing past your face, no vibration beneath your feet, and the coffee in your cup sits perfectly still, its surface a mirror of the quiet world around you. To your senses, you are at rest, but the reality is that you and everything you have ever known are currently caught in a gravitational trap of such staggering proportions that your brain is biologically designed to ignore it. We have spent the better part of human history believing we were the center of a static, predictable theater. We looked at the hazy band of the Milky Way and saw a river of milk, a path for souls, or a fixed ceiling. But this is not speculation, it is measured fact. The Milky Way is not drifting aimlessly. We are being pulled. Our entire galaxy, with its 400 billion stars and its 100,000 light-year span, is effectively a leaf caught in a much larger, much more violent current, and that current is leading us directly toward the subjects of our investigation. To understand the 5 colossal galaxies we are about to explore, you first have to understand the trap we are already in. You are currently living through a cosmic collision that started before the first complex life emerged in our oceans and won't finish until long after our sun has faded into a white dwarf. We are moving toward a region of space so massive it effectively anchors our entire corner of the universe. For decades, this was a mystery, a law gap in our understanding of why we were moving so fast. Astronomers could feel the pull, but they couldn't see the source. They called it the zone of avoidance, a part of the sky hidden behind the thick dust and gas of our own galactic plane. It was like being in a dark room and feeling a massive weight enter, sensing the floor tilt, but having no flashlight to see what had arrived. When we finally found the flashlight, X-ray, and infrared telescopes that could peer through the dust, we didn't just find a few stars. We found the architects of the universe. We found galaxies that make our own look like a grain of sand on an endless beach. The data is established. Our Milky Way is a barred spiral. It is beautiful, with curving arms of gas and dust where new stars are born every single day. It is 100,000 light-years across. If you could travel at the speed of light, 186,000 miles per second, it would still take you 1,000 centuries to cross home. That is longer than modern humans have existed. It is longer than every civilization, every war, and every discovery combined. But in the grand hierarchy of the cosmos, the Milky Way is merely a middle-class suburb. As we scale up, we move from spiral beauties to the elliptical giants. And here is the first complication in our narrative. In the universe, size comes at a price. The most colossal galaxies ever discovered are not just larger versions of our home. They are fundamentally different entities. They are what we call red and dead elliptical graveyards. While the Milky Way is vibrant and full of the complex structures of spiral arms, the giants we are looking for have traded their beauty for raw mass. They are featureless ovals of old, dying stars. They grew to their impossible scales through a process of galactic cannibalism, swallowing their neighbors whole over billions of years. Think of it like this. If the Milky Way is a thriving, diverse city with new buildings going up every day, these colossal galaxies are massive, sprawling mausoleums. They have conquered everything around them, but they have lost the ability to create anything new. They have used up their gas. They have quenched their star formation. They are quiet giants in repose. We used to think these monsters were rare accidents. We believed they were outliers that defied the neat and tidy rules of physics we learned in school. But as our instruments improved, from William Herschel's homemade mirrors in the 1780s to the James Webb Space Telescope today, we realized that these giants aren't accidents. They are the inevitable result of gravity's long game. They sit at the nodes of the cosmic web, invisible filaments of dark matter that act as a scaffold for the entire universe. These galaxies are situated at the intersections of these cosmic highways, where gravity is strongest and where the food is most plentiful. They haven't just grown, They have been fed. Before we begin our countdown of the 5 most colossal galaxies ever confirmed, we have to address the most terrifying aspect of their existence: their hollow hearts. Multiple independent teams have confirmed a core paradox. In the most crowded places in the universe, the centers of these trillion-star giants, there is an underpopulated void. Repeated mergers of supermassive black holes have acted like a cosmic broom, scouring the centers of these galaxies and flinging hundreds of billions of stars into the dark. The very events that made these galaxies the largest in existence also ripped the hearts out of them. We are about to meet the emperors of the void. We will see a galaxy with jets so long they could line up 160 Milky Ways end to end. We will explore a cannibal king that has undergone at least 76 major mergers, and we will look into the event horizons of black holes that are 50 billion times the mass of our sun, regions of space so large they could engulf our entire solar system 16 times over. This is not science fiction. This is the edge of observable reality. It is a place where matter, gravity, and time behave in ways that challenge every assumption you have about how the universe is supposed to work. If you enjoy these deep investigations into the scale of our existence and the invisible forces that shape our reality, subscribe now. The investigation begins with our first monster. To understand the giants that anchor the deep universe, we must first look at our own average home. The Milky Way is a barred spiral galaxy, a beautiful pinwheel-shaped structure of gas, dust, and light. It is 100,000 light-years wide. The data is established. If you could travel at the speed of light, 186,000 miles per second, it would still take you 100,000 years to cross from one edge of our home to the other. Humanize that number for a moment. 100,000 years is a span of time longer than modern humans have existed as a species. It is a duration longer than every empire that has ever risen, every war that has ever been fought, and every invention from the wheel to the microprocessor combined. This is not speculation. When you look at the stars tonight, you are seeing a structure so vast that its scale is measured not in miles, but in the time it takes for civilizations to rise and fall. Our sun is just one of roughly 400 billion stars that call this galaxy home. We are tucked away 26,000 light-years from the galactic center in a quiet, suburban neighborhood called the Orion Arm. We are moving around the center of our galaxy right now at a speed of about 500,000 miles per hour. Even at that tremendous velocity, it takes our solar system about 250 million years to complete a single lap. Astronomers call this a cosmic year. Think about what that means for your history. The last time the Earth was in this exact position in its orbit around the galaxy, dinosaurs had not even appeared yet. The most complex life on this planet was simple marine organisms drifting in a primordial sea. In the entire time that the most famous reptiles walked the Earth, our solar system did not even complete one full lap. This is measured fact. We live in a home so large that a single year for the galaxy encompasses nearly the entire history of complex life. Despite this, the space inside our galaxy is almost unimaginably empty. We live on a crowded planet, surrounded by billions of people and familiar with the density of cities. But outside our solar system, emptiness is the rule. To visualize this, imagine shrinking our sun down to the size of a single grain of sand. Our nearest stellar neighbor, Proxima Centauri, would be another grain of sand sitting roughly 4 miles away. The space in between is a void so perfect it makes a laboratory vacuum look crowded. This is why, despite containing 400 billion stars, galaxies can pass right through each other without any two stars ever actually colliding. For most of human history, we assumed the Milky Way was the entire universe. We saw that hazy band of light, the Via Lactea, or Milky Road, and believed it was the limit of existence. It wasn't until the 1920s that a single man at the Mount Wilson Observatory changed our reality forever. Multiple independent teams confirmed the findings of Edwin Hubble, who proved that the fuzzy smudges in our telescopes weren't clouds of gas, but island universes themselves. He showed that the Andromeda Nebula was actually 2 million light-years away, an entirely separate galaxy as large as our own. Suddenly the universe went from having 400 billion stars to having 2 trillion galaxies, each with its own billions or trillions of suns. And this is where our sense of scale finally begins to break. In this grand hierarchy, our Milky Way is merely a middle-class suburb. To understand the difference between our home and the colossal galaxies we are about to investigate, we use a concrete analogy. Imagine you shrunk the Milky Way down to the size of a standard dinner plate, about 10 inches across. On this scale, the entire 100,000 light-year span of our galaxy is something you can hold in your hands. Now imagine the first of the giants we are approaching, IC1101. If the Milky Way is that dinner plate, IC1101 is the size of a large Olympic-sized swimming pool. This isn't just a difference in size, it is a difference in reality. Our home plate holds 400 billion stars, but the swimming pool of IC1101 holds 100 trillion. If you started counting those stars today at a rate of 1 star per second, it would take you 3 million years to finish. But as we scale up from the dinner plate to the swimming pool, something fundamental changes. This is what the data says. In the universe, size comes at a price. As a galaxy grows to these colossal proportions, it loses the very things that make the Milky Way beautiful. Our home is a spiral beauty, full of complex arms, vibrant gas, and the constant birth of new stars. IC1101 and its colossal kin are elliptical giants. They are featureless ovals of old, dying stars. Astronomers call these entities red and dead. They have traded their structural complexity for raw mass. Like a fire that has burned all its wood, these giants have used up their gas and quenched their star birth. They are cosmic graveyards, mausoleums that have conquered everything around them through galactic cannibalism, swallowing smaller galaxies whole for billions of years. We used to think these monsters were rare accidents, outliers that defied the tidy rules of physics we were taught. But as our instruments improved, from the homemade mirrors of William Herschel in 1790 to the infrared eyes of the James Webb Space Telescope, we realized these giants were inevitable. They are the architects of the void, sitting at the nodes of the cosmic web. They are situated at the intersections of invisible highways of dark matter, where gravity is strongest and where they have been fed by the universe itself since the Big Bang. The investigation we are about to undertake is a journey into these extremes. We are going to look at objects so large that Voyager 1, the fastest object humans have ever built, would take 100 billion years just to cross a single one of them. That is a span of time nearly 10 times longer than the universe has currently existed. We are leaving the comfort of our dinner plate and diving into the pool. We are moving from the vibrant city of the Milky Way into the sprawling, quiet mausoleums of the colossal. If you enjoy these deep investigations into the scale of our existence and the invisible forces that shape our reality, subscribe now. The investigation begins with our first monster. We begin our investigation with a discovery that essentially broke the existing record books the moment it was published. In early 2022, a team of astronomers using the LOFAR, low-frequency array, network in Europe announced the existence of a structure so vast it seemed to defy the limits of what a single galaxy could produce. They named it Alcyoneus. What makes Alcyoneus the perfect starting point for our journey is its deception. If you were to look only at its body, the central collection of stars, gas and dust, you would see something remarkably ordinary. In fact, the stellar core of Alcyoneus is actually smaller than our own Milky Way, containing roughly 240 billion solar masses of stars. To a casual observer, it would look like just another unremarkable speck in the constellation Leo. But here is our first complication. A galaxy's reach can be far greater than its physical borders. While its heart is modest, Alcyoneus has effectively weaponized the space around it. This is what the data says. Stretching out from the center of this average galaxy are two colossal jets of plasma that reach across 16 million light-years of space. To visualize that scale, you would have to line up 160 Milky Ways end-to-end to equal the length of this single structure. If the Milky Way is a single city, Alcyoneus is a city that has managed to stretch its power lines across an entire continent. This is confirmed science, and to understand how an ordinary galaxy does this, we have to look at the technical term for what Alcyoneus represents, a giant radio galaxy. In plain English, a giant radio galaxy is a system that has stopped growing its body and started focusing its energy into its reach. Most galaxies, like our own, keep their matter close. They hold on to their gas to build new stars. But Alcyoneus is a machine of a different order. It takes the matter falling toward its central supermassive black hole, and instead of consuming it all, it accelerates it to nearly the speed of light and blasts it out into intergalactic space in two narrow, focused beams. Think of it like a high-pressure fire hose. These jets are made of plasma, a superheated state of matter where atoms are ripped apart into a soup of charged particles. These particles are accelerated by intense magnetic fields around the black hole, creating a line of fire that maintains its direction for millions of years. The scale of these jets is so extreme that they have moved beyond the territory of the galaxy itself. They have pushed out into the intergalactic medium, the nothingness that exists between galaxies. In plain English, the intergalactic medium is the loneliest place in the universe, a region so sparse that it contains only a few atoms per cubic meter. But when the jets of Alcyoneus hit this thin gas, they don't just disappear. They slam into it like a jet engine hitting a wall of air, inflating massive radio lobes. These lobes are effectively giant bubbles of energy and magnetic fields. They are the ghosts of 16 million light-years. They are invisible to human eyes, but in the radio spectrum, they glow with more energy than entire clusters of galaxies. Multiple independent teams have confirmed that these lobes are the largest structures ever created by a single galactic entity. This brings us to the deeper layer of the mystery. Why is an average-sized galaxy doing this? This is not speculation. The data suggests that Alcyoneus is situated in a region of space that is unusually empty, even for the intergalactic void. Because there is no crowding around it, its jets have been able to expand without being disrupted by the gravity of other galaxies. It is the ultimate expression of a lonely giant, allowed to reach its full, terrifying potential because it has no neighbors to stop it. To humanize this scale, imagine you are on a planet orbiting a star in a galaxy that Alcyoneus has targeted with its jet. The danger is established. You would not see a sudden explosion. You would be caught in a radiation storm that lasts for millions of years. The hypervelocity particles, microscopic bullets moving at nearly the speed of light, would relentlessly bombard your atmosphere. They would strip away the ozone layer, damage the very DNA of living cells, and turn a once vibrant world into a sterile, irradiated husk. This is the reach of a giant. It shows us that a galaxy's importance isn't just measured by how many stars it holds, but by how much of the universe it can influence. Alcyoneus has proven that a small heart can drive a massive structure. But as we leave this ghost of 16 million light-years behind, we must ask, what happens when galaxies aren't lonely? What happens when three of these monsters are forced into the same room? The investigation is ongoing, and we are the species doing it. If you enjoy these deep dives into the invisible architecture of our universe, subscribe now. We are moving from the lonely ghost to a scene of absolute chaos. But as we leave the ghost of Alcyonius behind, we must move from the quiet of the intergalactic void into a scene of absolute, unmitigated chaos. To understand how a galaxy reaches the colossal scales of our final three titans, we have to look at their youth. And in the universe, youth is not a period of peaceful growth, it is a massacre. This is confirmed science. Astronomers have recently begun to find what they call quasar triplets. To appreciate the rarity of this, you have to understand that galaxies are typically spread out across millions of light years of nothing. Seeing one active, ravenous black hole is a rare opportunity for study. Seeing two is a cosmic event, but seeing three of these monsters locked in a gravitational struggle in the same neighborhood of space was, for a long time, considered almost statistically impossible. Multiple independent teams have now confirmed that these triplets are real. This is not a trick of the light or a gravitational lens creating an optical illusion. These are three distinct, massive galaxies, each hosting its own supermassive black hole, all being forced into a room that is far too small for them. Think of it like this. Imagine three major cities, each powered by its own massive high-energy power plant. Now imagine that those cities are drifting toward each other, and as they get closer, those power plants begin to fail. They start to overload, spewing raw radiation and blinding light into the sky, drowning out everything else. This is what a quasar triplet represents. These aren't just galaxies, they are battlefields where the very architecture of the universe is being torn apart and remade. This is what the data says. These triplets represent the chaotic youth of a colossal galaxy. They are the origin story of the giants. When we see three quasars this close together, we are witnessing a chain reaction of collisions. One galaxy strikes another, and as they merge, the chaos draws in a third. It is a scene of gravity-induced violence that can last for hundreds of millions of years. As these three galaxies spiral toward each other, the gas and dust that should be making stars are instead funneled toward the three central black holes. As that matter falls in, it heats up to millions of degrees, creating a quasar, an object so bright it can outshine its entire host galaxy by a factor of 1,000. That is established geometry. A quasar is like a searchlight held next to a candle. The candle of the stars is still there, but you can no longer see it against the glare of the black hole's feeding frenzy. But here is the deeper complication, the part that challenges our idea of growth. We often think of light and energy as the signs of a thriving system. In the case of these triplets, the opposite is true. This represents a battlefield of overlapping radiation storms. When you have three quasars active at once, the space between them is flooded with X-rays and gamma rays. The energy is so intense that it creates a phenomenon known as quenching. In plain English, the very energy that makes these galaxies visible to us across billions of light years is the same energy that is killing them from the inside out. This is not speculation. The radiation from the quasars is so powerful that it physically blasts the gas out of the galaxies. It acts like a cosmic wind, stripping away the raw material needed to create new stars. It heats the remaining gas to such extreme temperatures that it can no longer cool down and collapse into a sun. The result is a grim paradox. At the moment when these galaxies are at their most brilliant, shining like lighthouses across the observable universe, they are simultaneously becoming sterile. They are quenching their own futures. They are trading their ability to create life for a brief, violent burst of cosmic power. Measured directly by our best telescopes, These systems show us the unstable dance of gravity's long game. When three supermassive black holes merge, the physics becomes unpredictable. They don't just fall into each other, they slingshot each other around like stones in a cosmic flail. Occasionally, one of the three is ejected entirely, flung into the intergalactic dark at millions of miles per hour, leaving the other two to settle into a deadly embrace. This massacre phase is the only way a galaxy can jump the gap from average to colossal. It has to be born in fire. It has to survive a neighborhood where galaxies are consumed as easily as oxygen. Every colossal galaxy we will see in the final chapters of this investigation was once a system like this. They are the survivors of the massacre. They are the red and dead mausoleums that remain after the quasars have gone quiet and the radiation storms have cleared. They reached the top of the food chain not through a peaceful evolution, but by being the last thing standing in a triple collision that lasted an eon. You are witnessing the construction of a monster. The investigation is ongoing, and we are the species doing it. We are looking at the blueprints of the cannibal king we are about to meet. If you enjoy these deep investigations into the violent architecture of our universe and the data that confirms our smallness, subscribe now. The investigation moves from the chaos of youth to the reigning emperor of the void. We have reached the reigning champion. After moving through the lonely ghosts of the intergalactic medium and witnessing the chaotic massacre of triple galaxy collisions, we arrive at the current apex of the known universe, IC1101. It is the single most massive collection of stars ever confirmed by modern astronomy. This is what the data says. IC1101 is an elliptical giant located in the heart of the Abell 2029 galaxy cluster, roughly 1 billion light-years from Earth. Its name is remarkably boring, an entry number in a celestial catalogue created over a century ago, but the reality it represents is a cosmic monster so vast that your brain will struggle to process it. To understand its scale, we must return to our standard of measurement, the Milky Way. Our home galaxy is roughly 100,000 light-years across, a distance that would take 1,000 centuries to cross at the speed of light. IC1101 is estimated to be 6 million light-years across. If the Milky Way is a standard 10-inch dinner plate, IC1101 is the size of an Olympic-sized swimming pool. If you placed this galaxy where our Milky Way currently sits, it would not just engulf us, it would swallow our entire cosmic neighborhood. The Andromeda Galaxy, currently 2.5 million light-years away, would find itself buried deep inside IC1101's massive body. The Triangulum Galaxy and dozens of our satellite dwarf galaxies would simply vanish, absorbed into this giant's vast structure. This is not speculation, it is established geometry. IC1101 holds an estimated 100 trillion stars. That is 250 times more stars than the Milky Way. Humanize that number for a moment. If you started counting those stars today at a rate of 1 star per second without ever stopping to eat or sleep, it would take you over 3 million years just to finish the count. This isn't just a difference in size, it is a fundamental shift in reality. The story of how we found this emperor begins in 1790 with William Herschel, the musician turned astronomer who mapped the Milky Way with a homemade telescope. On a June night, he pointed his instrument toward the constellation Virgo and noted a faint, fuzzy blob of light. For over a century, that smudge remained a mystery, logged as just another unremarkable nebula. It wasn't until the 20th century, with the development of the cosmic distance ladder and advanced spectroscopy, that we realized the fuzzy blob was an entire island universe situated at a distance so great that its light has been traveling for 1 billion years to reach us. When the photons hitting our telescopes today first left IC1101, life on Earth was still composed of simple, single-celled organisms. But here is the complication that separates IC1101 from the neat and tidy spiral galaxies we see in textbooks. This emperor did not grow through peace. It is a monument to billions of years of gravitational violence. The data is established. IC1101 is a cannibal. It grew to its impossible proportions by systematically swallowing its neighbors. Situated at the very bottom of a massive gravitational well, IC1101 acts like a trap. For eons, smaller galaxies that ventured too close to the cluster's center were caught in its grip. They spiraled inward, getting torn apart by tidal forces and consumed over millions of years. Measured directly by our best instruments, astronomers estimate that IC1101 has undergone at least 76 major mergers. Each of those events involved a substantial galaxy being ripped apart and absorbed into IC1101's core. Countless other minor dwarf galaxies, too small to even register as a major meal, have been digested over the galaxy's long history. This leads us to a deeper, more unsettling layer of the law. In the universe, size comes at a price. While IC1101 is the largest galaxy we've ever found, it is also what astronomers call red and dead. It has traded its beauty and complexity for raw mass. If you look at our Milky Way, you see a vibrant spiral with elegant arms full of gas and dust, the raw materials for birth. But the violent process of cannibalism has a side effect. It destroys structure. The repeated collisions and gravitational chaos have stirred IC1101's stars like ingredients in a cosmic bowl, erasing any original spiral arms it might have possessed. What remains is a featureless yellow-red oval. This is confirmed science. The very mergers that made IC1101 a giant also quenched its ability to create new life. The heat and radiation from billions of years of collisions either used up the galaxy's gas supply in intense starbursts or blasted it out into intergalactic space entirely. IC1101 has run out of fuel. Think of it like this. If the Milky Way is a thriving, diverse city with new buildings going up every day, IC1101 is a massive, sprawling mausoleum. It is a kingdom that has conquered all of its neighbors but has no children to carry on its legacy. The 100 trillion stars that exist there now are almost all old, dying suns. One by one, over the next several trillion years, they will wink out, and because the gas is gone, there will be no new generation to replace them. This giant is currently sitting in a state of quiet repose, a dormant predator, at the center of the Abel cluster. It sits at a node of the cosmic web, where invisible filaments of dark matter have been feeding it mass since the Big Bang. It is the ultimate expression of gravity's long game, a featureless cosmic graveyard that traded its vibrant spiral heart for the stability of a giant. But as we look deeper into the center of this cannibal king, we find a mystery that even its massive size cannot explain. We expect the center of the universe's largest galaxy to be the most crowded, vibrant place in existence. Instead, we find a void. The investigation is ongoing, and we are the species doing it. To understand why the king has a hollow heart, we must look at the law gap that your typical space documentary completely ignores. If you enjoy these deep investigations into the scale of our existence and the invisible forces that shape our reality, subscribe now. The investigation moves from the mass of the giant to the paradox at its center. When we look into the center of a galaxy like our own, we expect to see a concentration of light and life. In the Milky Way, the galactic center is a blindingly bright region where stars are packed together with a density thousands of times greater than what we experience in our quiet neighborhood. If you lived on a planet near our galactic core, the night sky would not be dark. It would be filled with the overlapping light of so many suns that you could read a book by the starlight alone. Naturally, when we turn our telescopes toward the colossal titans of the universe, entities like IC1101, we expect this effect to be magnified to a terrifying degree. We expect the center of a 100 trillion star empire to be the most crowded, vibrant, and energy-dense place in the known cosmos. But here is the law gap that your typical space documentary completely ignores. The data shows the exact opposite is true. When astronomers used the Hubble Space Telescope to peer into the heart of IC1101, they encountered what is now called the core paradox. Instead of a brilliant peak of light, they found a massive, underpopulated void. This is confirmed science. The center of the largest galaxy ever discovered is unusually faint and strangely hollow. It is a region of space roughly 14,000 light-years across that has been effectively emptied of its stars. To humanize that 14,000 light-year number, you have to realize that this empty core is actually larger than many entire galaxies in our universe. If you took our neighbor, the Large Magellanic Cloud, and dropped it into the center of IC1101, it would fit comfortably inside this hollow heart, with room to spare. This isn't an accident, and it isn't speculation. Multiple independent teams have confirmed that this void is the result of a violent physical process known as core scouring. To understand how you empty the center of a trillion-star galaxy, you have to look at the Cannibal King's past. As we discussed, IC1101 grew by swallowing at least 76 major galaxies. But when two galaxies merge, their stars don't just blend together peacefully. Their central supermassive black holes begin a deadly, billion-year-long dance. These black holes, each weighing millions or billions of times the mass of our Sun, spiral toward the center of the newly merged system. As they sink inward, they form what scientists call a binary black hole, two titans locked in a gravitational embrace. As they orbit each other, they interact with any star that wanders too close to the center. Think of it like a cosmic slingshot. Through a process called gravitational friction, these merging black holes transfer their energy to the surrounding stars, flinging them outward at thousands of miles per second. The data is established. These black holes act like a cosmic broom, systematically scouring the center and throwing stars into the far reaches of the galaxy's halo or out into the intergalactic dark entirely. Imagine you are on a planet orbiting a star near that core. You are living in the most prime real estate in the galaxy, surrounded by the glow of a billion suns. Then the broom arrives. You wouldn't feel a sudden jerk, but over millions of years, the gravity of the passing binary black holes would alter your star's orbit. Slowly, relentlessly, you would be evicted. You would be flung away from the warmth and light of the galactic center and cast into the stellar exclusion zone, the lonely, underpopulated outskirts of the giant. Measured directly by our best instruments, astronomers estimate that this process has scattered hundreds of billions of solar masses worth of stars away from the heart of IC1101. That is an amount of stellar material equal to the entire mass of the Milky Way, just gone. Ripped from the center and discarded like waste. This is the deeper layer of the law that changes how we view these giants. We often frame galactic growth as a win, but for the stars living at the center, it is a catastrophe. The heart of the largest galaxy in the universe is not a thriving metropolis. It is a graveyard of missing suns. It is a monument to the fact that when you reach a certain scale, you physically cannot maintain a crowded center. The very events that make you a colossus, the mergers and the black hole growth, are the same events that rip the heart out of you. This core paradox is our first real hint at the law of loss. It reveals a universe where the most successful entities are also the most hollowed out. IC1101 is a king that has conquered everything, but in doing so it has created a throne room that is essentially an empty tomb. But the scouring of the core is only half of the tragedy. As we move from the hollowed-out center to the overall structure of these giants, we find another complication. We find that these galaxies haven't just lost their hearts, they have lost their very identity. They have traded the beautiful, complex, spiral life of our Milky Way for something far more stable, but far more dead. The investigation is ongoing, and we are the species doing it. We are beginning to see the true cost of being a giant. If you enjoy these deep investigations into the hidden ghost stories of our cosmos and the data that reveals the hollowed-out nature of the largest objects in existence, subscribe now. Our journey into the law of loss continues. We have looked into the hollowed-out hearts of these monsters, but now we must zoom out and look at the bodies themselves. And here we encounter a paradox that challenges our human intuition about growth and success. This is confirmed science. The biggest galaxies in the universe are, by almost any visual standard, the most boring. If you were to look at a high-resolution image of our Milky Way, you would see a masterpiece of cosmic architecture. You would see elegant, curving spiral arms, dark lanes of dust where new worlds are currently forming, and vibrant clusters of young blue stars. Our home is a spiral beauty. It is complex, it is dynamic, and it is visually loud. But as we move up the scale to the titans like IC1101, all of that complexity vanishes. The data is established. The 5 most colossal galaxies ever discovered are not spirals. They are what astronomers call elliptical galaxies. In plain English, an elliptical galaxy is a featureless yellow-red oval of old stars. It has no arms, it has no dust lanes, it has no internal structure. It is essentially a giant, smooth cloud of suns. To understand why the universe's greatest winners look so unremarkable, we have to use a domestic analogy. Imagine a fireplace in your living room. When you first start a fire, it is a scene of intense complexity. You have individual logs, dancing orange flames, crackling sounds, and shifting shadows that play across the walls. This is the spiral phase of a galaxy, active, burning, and intricate. But imagine that fire continues to burn for a very long time. Imagine it has consumed every piece of wood in the house. Eventually the dancing flames disappear. The crackling stops. What you are left with is a massive, uniform pile of glowing red embers. It is stable, it is incredibly hot, and it contains more total energy than the original flames, but it is featureless. It is a red and dead fire. This is what the data says. Colossal galaxies are cosmic fires that have burned all their wood. They have reached the anti-spiral fate. In the Milky Way, we have vast reservoirs of cold hydrogen gas. This gas is the wood of the galaxy. It is the raw material that gravity uses to build new stars like our Sun. Because we still have gas, we still have life. We are still building. But the giants we are investigating have undergone a process called quenching. This is not speculation. The very act of becoming a giant is what kills a galaxy's ability to create. When these colossal entities were formed through the massacre phase of mergers we discussed earlier, the violence was so extreme that it used up the gas supply in a desperate, brief burst of star formation. The heat from the mergers and the radiation from the central black holes then blasted the remaining gas out of the galaxy entirely. The result is a system that has run out of fuel. Measured directly by our best telescopes, the star formation rate in a galaxy like IC1101 is essentially zero. It is no longer a nursery, it is a mausoleum. Think about what this means for the reality of scale. We often equate bigger with better or more advanced. In our own cities, growth usually leads to more complexity, more roads, more buildings, more diverse neighborhoods. But in the architecture of the void, the opposite is true. Scale comes at the cost of life. As these galaxies grew to hold 100 trillion stars, they traded their vibrancy for stability. A spiral galaxy like the Milky Way is beautiful, but it is fragile. Its structure depends on a delicate balance of rotation and gas pressure. A single major collision can tear our spiral arms apart, but an elliptical giant like IC 1101 is the most stable structure in the universe. It is a finished object. It has already had all its collisions. It has already survived the massacre. It is a featureless emperor that can now sit in the dark for trillions of years without changing. Multiple independent teams have confirmed that this lack of structure is the signature of a red and dead system. The yellow-red color of these giants tells us that there are no young blue stars left. Blue stars are the ticking clocks of a galaxy. They are massive, they burn hot, and they die young. Because IC 1101 is no longer making new stars, all its blue stars died out billions of years ago. What you are seeing when you look at that featureless oval is a collection of 100 trillion old, small red suns that are slowly winking out. This is the second law gap. The most massive structures in the universe are not thriving systems. They are graveyards of stars that have traded their complex identity for raw, stable mass. They are anti-spirals. Humanize this for a moment. If you lived on a planet inside the Milky Way, you would look up and see a sky of diversity, different colors of stars, dark clouds of gas, and the bright band of the galactic disk. If you lived on a planet in the heart of IC 1101, your sky would be a monotonous, unchanging glow of old red light. There would be no new stars appearing in the sky. There would be no dark nebula to spark your curiosity. You would be living in the ultimate stable environment, but it would be an environment of absolute stagnation. We find ourselves in a strange position. We are small, we are unremarkable, and we live in a middle-class suburb of the universe. But because we are small, we are still complex. Because we haven't swallowed all our neighbors, we still have our wood left to burn. We are the dancing flames in the fireplace, looking over at the massive pile of cooling embers and realizing that to grow to that scale is to lose the very things that make us vibrant. But as we contemplate this red and dead fate, a new question arises. If these galaxies have used up all their gas and are no longer growing through internal birth, how do they stay so massive? How does an entity with 100 trillion stars keep itself together in a universe that is constantly trying to pull it apart? The investigation is ongoing, and we are the species doing it. The answer doesn't lie in the stars we can see, but in the invisible architecture that was there before the stars even existed. If you enjoy these deep investigations into the existential cost of scale and the data that reveals the true nature of the cosmos, subscribe now. We are moving from the dead stars to the invisible skeleton of the universe. We have spent this investigation looking at things that glow, at the 100 trillion stars of IC 1101, the radiation of quasar triplets, and the 16 million light-year jets of Alcyonius. But now, we must address the most unsettling layer of the law, a reality that challenges the very way you see the universe. This is not speculation, it is measured fact. The massive, light-filled galaxy we have been describing is merely the visible tip of a much larger, much darker structure. To understand this, you have to look at the math that makes astronomers lose sleep. When we measure the way stars move in the outer edges of a giant like IC 1101, the physics simply stops making sense. The data is established, The stars are moving far too fast. Based on the gravity of the 100 trillion suns we can see, the galaxy should be flying apart. It would be like watching a merry-go-round spin so quickly that the riders should be flung into the trees, yet they remain perfectly, impossibly glued to their seats. This is confirmed science. There is something else there, something that does not emit, reflect, or absorb light. We call it dark matter. And in a colossal system like IC1101, it isn't just a minor ingredient, it is the architect of the entire structure. While the stars account for a staggering amount of mass, they are a rounding error compared to the invisible weight holding them together. Measured directly by its gravitational influence, dark matter makes up roughly 90% of the total mass of this cosmic giant. Think of it like this. If you were looking at a vast, dark ocean at night and saw a single, glowing buoy bobbing on the surface, you might think the buoy is the only thing there. But beneath that small point of light is a massive, invisible mountain of iron and cable reaching down miles into the abyss, anchoring that light against the currents of the sea. IC1101 is that buoy. The stars are just the decoration on an invisible mountain. This leads us to the true scale of the monster. We previously stated that the visible body of IC1101 is 6 million light-years across. But multiple independent teams have confirmed that the galaxy sits inside a dark matter halo that extends far beyond the reach of starlight. This halo may reach out tens of millions of light-years into the void. This is not just a difference in size, it is a fundamental shift in our definition of where a galaxy ends and where nothingness begins. You are currently living in a universe that is built on a scaffold you cannot see. This scaffold is known as the cosmic web. Imagine a trillion-mile-long invisible skeleton made of primordial gas and dark matter filaments stretching across the entire observable universe. This is established geometry. These filaments act like cosmic highways, and where these highways intersect, gravity becomes an irresistible force. We call these intersections nodes. IC1101 is not a random accident of nature. It is the inevitable result of its geography. It is situated at one of the most powerful nodes in our corner of the cosmos, at the very bottom of a massive gravitational well. It has been anchored to this scaffold since the Big Bang, and for 13 billion years, these invisible filaments have been feeding this monster. We often wonder how a red and dead galaxy, one that has used up all its internal gas, could ever grow to such a colossal scale. The answer is that it was never alone. The cosmic web has acted like a series of intravenous tubes, funneling smaller galaxies and pockets of gas directly into IC1101's maw for eons. It hasn't just grown, it has been methodically constructed by the invisible architecture of the universe. The data shows that this invisible scaffold is the only reason these giants can exist at all. Without the dark matter halo acting as a gravitational glue, the heat from the quasar triplets and the violence of 76 major mergers would have shattered the galaxy and scattered its 100 trillion stars like dust in a windstorm. The scaffold is what allowed the Cannibal King to survive its own violent rise to power. To humanize this scale, we use a concrete analogy of invisible terrain. Imagine you are walking through a field and you find enormous tracks pressed deep into the sand. You can measure the stride length, the depth of the heel, and the exact bearing of the path, but you have no idea what made them because the creature itself is invisible. That is how we study the dark matter scaffold. We cannot see the filaments of the cosmic web, but we can see the way they bend the light of distant galaxies behind them. We can see the way they tug on the 100 trillion stars of IC1101, pulling them into a stable oval. This is the deeper layer of the law. You are a participant in a reality where the most important structures are the ones you will never see. You feel nothing as you move through space, but you are currently being guided by these same invisible contour lines. The Milky Way is currently drifting along a filament of this same web, being pulled toward a node that will, billions of years from now, create a new giant. Measured directly by our best instruments, the cosmic web reveals that the universe is not a collection of isolated islands. It is a single, interconnected machine. IC1101 is simply the place where the machine has worked the longest and the hardest. It is a monument to the invisible forces that have been shaping matter since the first atoms formed in the cooling wake of the Big Bang. But even a monument built on an invisible scaffold cannot last forever. As we contemplate the feeding of this monster, we must also contemplate the inevitable moment when the food runs out. We must look at the final, quiet fade of the universe's greatest emperors. The investigation is ongoing, and we are the species doing it. To understand the end of the giants, we must look past the dark matter and into the long, inevitable dark. If you enjoy these deep investigations into the invisible architecture of our existence and the data that confirms our smallness, subscribe now. The investigation moves from the scaffold to the final fade. What happens when the cannibal runs out of victims? Throughout this investigation, we have seen how these colossal titans reached their impossible scales through the systematic consumption of their neighbors, anchored by an invisible scaffold that has fed them since the Big Bang. But we are now approaching a period of the cosmic timeline where the rules of the game change. This is not speculation, it is established geometry, the very force that is currently pulling us toward these giants. Gravity is slowly losing its battle against a much more mysterious and much more relentless opponent, dark energy. The data is established, space itself is expanding, and that expansion is accelerating. For a galaxy like IC1101, which sits at the center of a rich cluster, this means its days of growth are strictly numbered. Eventually, the expansion of the universe will become so fast that it will carry potential victims away from the giant faster than gravity can reel them in. The invisible highways of the cosmic web that once funneled matter into the cannibal king's maw will eventually stretch and snap. The king will be left alone. Multiple independent teams have confirmed what this isolation looks like on a multi-billion-year scale. One by one, the distant galaxy clusters that currently surround IC1101 will fade from view, their light no longer able to reach across the ever-widening void. If any observers were still left on a planet inside that giant, they would look up to see a night sky that was slowly, relentlessly turning to absolute black. The universe, which currently holds 2 trillion galaxies, would eventually appear to contain only one, the merged, featureless mausoleum they call home. But the isolation is only the beginning of the fade. We must now address the 100 trillion stars that give this giant its mass. This is what the data says. Star formation inside these colossal galaxies has already been quenched. They are no longer nurseries. They are graveyards of old, dying suns. One by one, those 100 trillion stars will begin to wink out. To humanize this timescale, consider the life of a star. Our own sun has about 5 billion years left before it fades. But in a giant like IC1101, the most numerous residents are red dwarfs, tiny, dim stars that burn their fuel so slowly they can shine for trillions of years. Measured directly by our best models, the smallest of these stars can live for up to 10 trillion years. 10 trillion years is a number that breaks our biological sense of time. To visualize it, imagine the entire history of the universe from the Big Bang until this exact second as a single day. On that scale, a red dwarf has barely finished its morning coffee, but even trillions of years have an end. Eventually, the gas and dust required to build new stars will be gone or dispersed too thinly to collapse. The era of starlight will draw to a close. The 100 trillion suns will become 100 trillion cold, dark cinders. This is confirmed science. These stellar corpses, known as white dwarfs, will spend the next quadrillion years cooling down. They will transition from glowing white to a dull, invisible state called a black dwarf, an object that no longer emits any light or heat. The galaxy will effectively vanish from the observable spectrum. This brings us to the honest uncertainty of our investigation. We are not entirely sure what happens to the matter itself. Some theories of particle physics, published in peer-reviewed literature, suggest that the very building blocks of atoms, the protons, are not eternal. They predict that over unfathomable time spans, perhaps 10 to the 34th power years, even the matter that makes up planets and dead stars will gradually dissolve into radiation. The giant will not just go dark, it will literally evaporate. And then we are left with the heart. At the center of this vanishing empire sits a supermassive black hole with 50 billion times the mass of our sun. For trillions of years, it has been the anchor of the galaxy, a region of space so large it could swallow our entire solar system 16 times over. But even this monster is subject to the laws of the long dark. Multiple independent teams have confirmed the process of Hawking radiation. Because of quantum mechanical effects near the event horizon, black holes are not truly black. They slowly leak particles and energy back into space. For a 50 billion solar mass titan, this process is unimaginably slow. The data is established. It would take roughly a Google years, a 1 followed by 100 zeros, for that black hole to fully evaporate. To understand that number, imagine you wanted to write it down. To write a Google out in full would require more paper than currently exists on Earth. It is a span of time so vast that everything we have discussed so far, the mergers, the quasar massacres, the entire history of the human race, is not even a rounding error in comparison. But trillions upon trillions of years from now, that black hole will eventually radiate away its last bit of energy and disappear in a final, quiet flash. When that happens, the last physical trace of the most colossal galaxy ever discovered will be gone. The particles that once made up 100 trillion stars will be spread out across an ever-expanding, ever-cooling, ever-darkening universe. This is the deeper layer of our investigation. We are currently witnessing these giants in their brief flowering of complexity. We live in a golden age of light and gravity, a momentary window in the cosmic timeline where matter has assembled itself into these magnificent, violent monuments. We are essentially looking at a cosmic garden in the middle of its only spring. We do not know if anything comes after the long dark, or if the expansion of space will simply continue forever. But the fact that we can stand on a small rocky planet, orbiting an unremarkable star, and map the death of a 100 trillion star empire is perhaps the most startling fact of all. We are the part of the universe that has developed the ability to look at itself and wonder about its own ending. The investigation is ongoing, and we are the species doing it. If you enjoy these deep investigations into the existential scales of our universe and the invisible forces that shape our reality, subscribe now. We have one final beat to cover. The iron in your blood, the oxygen currently filling your lungs, and the carbon that forms the very structure of your DNA are not just chemicals. They are artifacts. This is not poetry. It is chemistry. Every atom in your body was forged in the same type of nuclear furnaces that now lie cold and dark in the distant graveyards we have spent this hour investigating. The universe is a massive recycling program, and you are the latest iteration of its heavy elements. To understand your connection to the colossal, you have to look at the law of origin. The data is established early in the universe's history. There was only hydrogen and helium. There were no planets, no rocky ground to stand on, and no complex molecules to build a nervous system. The heavy elements required for life, the calcium in your bones and the silicon in your technology, had to be manufactured. They were cooked deep inside the cores of massive stars, the kind of blue giants that once lived fast and died young in the centers of galaxies like IC 1101 and Alcyonius. Measured directly by our understanding of stellar evolution, when those stars reached the end of their fuel, they didn't just go dark. They exploded as supernovas, scattering their guts across thousands of light years. That enriched gas eventually collapsed under its own gravity to form new stars and new planets. One of those clouds became our solar system. You are quite literally made of dead stars. You are star stuff, contemplating the end of all stars. This creates a startling reality as you sit in your room today. The atoms that make up your hand were once caught in the same violent gravitational currents we see in the triple quasar massacre. They have been part of the chaotic youth of a galaxy. They have been quenched by radiation storms. They have survived the scouring of a galactic core. You are the surviving residue of billions of years of cosmic violence. But as we contemplate our origin, we must also contemplate our reflection. This is what the data says. Our Milky Way is an unremarkable spiral. It is a middle-class suburb in a universe dominated by emperors. From the perspective of an observer in the heart of IC 1101, our entire galaxy is a dim, fuzzy smudge, barely worth a footnote in a celestial catalogue. Multiple independent teams have confirmed the staggering probability of this reflection. IC 1101 contains 100 trillion stars. Even if the recipe for life is incredibly rare, if only 1 in a trillion stars hosts a planet with an atmosphere, that still means there are 100 civilizations currently existing within that one giant alone. Somewhere in that 100 trillion star sea, another mind might be looking through a telescope right now. They might be mapping the suburbs of their local supercluster. They might be looking at a small, barred spiral galaxy 26,000 light years from its own center and wondering the same thing we are. Is anyone there? They see us not as we are now, but as we were 1 billion years ago, when our world was a silent rock inhabited only by single-celled organisms. We are looking at each other across a bridge of time that neither of us can ever cross. This leads us to the final, most interesting layer of the law. We often feel a sense of dread when we discuss the final fade, the idea that the 100 trillion stars will wink out, that the black holes will evaporate, and that the universe will return to a state of absolute, featureless dark. We feel small because we are brief. The human lifespan is less than a cosmic instant. But this is not speculation, it is the honest truth. The universe is indifferent, and that is precisely why we matter. The 100 trillion stars of IC 1101 do not know they are beautiful. The dark matter scaffold does not know it is the architect of the void. These are mindless forces obeying physical laws. But here, on a small rocky planet orbiting an ordinary star, the universe has developed the ability to look at itself. We have mapped the zone of avoidance. We have resolved the core paradox. We have measured the distance to the cannibal king. Whatever else we are the part of the universe that has woken up. We are the circuit that connects human consciousness to cosmic grandeur. The fact that a species that lives for 80 years can calculate the evaporation of a black hole in a Google years is the most startling fact of all. As you finish this investigation, the coffee in your cup is still still, your room is quiet, but the motion has not stopped. The expansion of space is still accelerating. Dark energy is already beginning to stretch the invisible highways of the cosmic web. One by one, the distant empires we've discussed are being carried away from us. We are living in the final golden age of visibility, the brief flowering of spring before the long dark. You are moving at 1.4 million miles per hour toward a destination you will never reach. You are made of the debris of stars that died eons before you were born. You are a participant in a mystery that is far larger than your ability to comprehend it, and you are learning faster than ever before. We are small. The universe is indifferent. And that is the most interesting thing we know. The investigation is ongoing, and we are the species doing it.